So, exercise, force and acceleration, and also gravitational forces. Number one, what is the weight of a 5.2 kg object? And also, we ask mass and weight. What are the differences? And many cases, commonly, some people think these are the same, but actually there are differences. Mass is the inertia, how much stuff is there, or how many neutrons, protons are actually in this substance. That's a property of the object. The weight is the gravitational force and the object experiences. So that's the weight. So, and of course, since the more mass, the more gravitational force it will experience. Normally on an planet, the gravitational force is proportional to the mass. Therefore, the more mass, more weight, more weight, more mass. That would be different. So then, but they are different. Weight is the gravity force on an object. It is proportional to the mass. So in fact, you see, if you think about an object acceleration as g, and that is caused by gravitational force divided by the mass. So the more mass, so the gravitational force, so g, the gravitational force g is actually times the mass times acceleration. Therefore, in many tests or papers, simply this mass equal force of gravity equal mass times acceleration. In other words, if that's sort of logically sort of going backwards, since we know it has this acceleration, so acceleration times mass must be equal to the force. So the gravitational force is this. So in this case, so that is actually the weight, the gravitational force. That's called the weight. Therefore, the weight is actually very easy. So is a gravitational force, which is the weight, and this is mass 5.2 times 9.8, and that it will give you 50.96 newtons. So the force is in units of newtons. So number two, what is a resulting acceleration when an unbalanced force of 100 Newton is applied to a 5 kilogram, typo here, object. So this is directly apply of the Newton's second law. So acceleration is the force and mass. So in this case, 500 Newton, 100 Newton, okay, and divided by 5 kilogram, and there will be actually 20 meters per second square. All right, so the mass is simple, but the idea is very significant. So the force is proportional to acceleration, okay, and the mass and acceleration is inversely acceleration is inversely proportional to the mass, so mass on the bottom. You just do the calculation, you get the acceleration. Now, number three, okay, what is the resulting acceleration when a 300 Newton force acting on an object with mass 3000 kg? Well, just to give you more exercise, this is exactly the same thing. So mass, okay, force 300, but in this same 3000 kilograms. And then, of course, 0.1 meters per second squared. So in this case, you see, because the mass is big, the acceleration is very small. So the last question is actually back to the regular motion. This time, the object is actually light. We will learn later down the road in the physical science, light is actually the energy travels, but it follows the same idea of velocity and distance relation. The distance, again, is velocity times t. So in this case, velocity is very fast. 3 times 10 to the 8 meters, which means a lot of distance. And the time in this case 20 minutes. So time is 20 minutes. Each minute, as you know, is 60 seconds. So therefore, we're converting it to seconds. So it's 1020 seconds. So what is the distance? What is the distance? Well, I leave this to you, the math. So then you have distance equals velocity times t. So you multiply this 1200 seconds, 3 times 10 to the 8 meters per second, and then you will get answer. So I'm not doing the math on the video, so you should calculate it, and then later convert to miles. Okay, what is the distance? So you will get an idea, what are the magnitude of the distances and time in the interstitial interplanet travels.